email discussions, and also took the chance of last IETF meeting for site meetings to converge on the view we have for this kind of solution. So what we did and also presented during last IETF is the categorization of the required protocol functions between mobility management control and data plane. So that was the main objective, to separate control plane from data plane in current mobility management solutions. So we came to a set of design objectives and draw some functional architecture which is flexibly deployable, and agreed on a kind of level of abstraction. So we want to abstract from DPN particularities and configuration specifics. So we had enough ideas to compile a first draft, which has been circulated and discussed and formed. And just before this IETF meeting, we published first draft, which is the outcome of the work team discussion. Next slide. So which protocol we are talking about? So this one is what we have now. It's a single box covering control plane, data plane. As an example, it's a PMIP6 local mobility anchor covering control plane, talking to the XDAS network, either using PMIP or if you have a P gateway in 3GPP, use a GPP-C. And that's a data plane, forwarding packets, doing encapsulation and QS. So if we separate the control from the data plane, we have something like this, which is pretty static one-to-one behavior. So the intention of the work team was to use any potential data plane node, either a router, a switch, serving these functions required for the LMA control plane, and use kind of configuration protocol and common semantics between the control and the data plane. So that's the scope of this work, to utilize between a client function and multiple agent functions, which are spread around in the data plane, and use a protocol which deploys the same policy description model and allows the LMA control plane to configure the required policies in any kind of data plane mode. Next slide.
Try to keep in the market area.
Oh.
That's annoying, sorry.
Prison? Yeah. All right. So that's a view, a simplistic view of the functional architecture. There is a client function, which is associated with a mobility control plane. I cannot point.
I know.
And there is an agent, which is associated with a data plane node configuration. So the protocol we're talking about is running between the FPC forwarding policy configuration client and agent. So the client is associated with a control plane function. As an example, an LMA control plane function. The agent is either collocated with a router or with a switch or with a network controller. Thank you. So the protocol we are specifying runs between the client and the agent. And the role of the client is to take the mobility control plane functions, commands for policy configuration, use this common protocol semantics between the client and one of multiple agents, and the role of the agent is to translate the generic model for policy configuration to the configuration particularities of the router, the switch, or the SDN controller as an example. Next slide. So what we needed is a generic description, a flexible description of policies in terms of encapsulation to IPFP, GRE, GTPU plane, and forwarding rules, and without being specific to router or switch configuration. So we came up with a construct, and it's only a construct, and it uses a logical port, which represents a kind of virtual next hop. So this construct of a logical port, it can be, it's just a terminology thing. It can be a logical next hop, a logical gateway, logical interface, whatever, but it's just a key to bind a set of configuration particularities for QS, for tunnel endpoints, And a configuration set is determined by one or multiple properties. The property is, for example, a tunnel. The property is a QoS. So having this construct of a logical port which binds one or multiple properties, we need forwarding rules. So forwarding means specifying traffic template, traffic selector, that forwards traffic to a particular port. And all traffic being directed to this logical port actually experiences the same policies. So it will be encapsulated to the same tunnel with the same tunnel endpoint. If there is a node which requires a different tunnel endpoint, use a new logical port and specify the associated properties. So in the next slide, we have a kind of illustration of this concept. So that's what the LMA control plane expects from a data plane node. Traffic coming in, being treated by means of QoS differentiation, traffic shaping, encapsulation, and packets are sent further. So without being specific to router configuration of TAN0, Ethernet 0 interfaces, or of physical ports at a switch, this model requires two things from the control plane. First is for each set of properties, use a new logical port and bind associated properties with it. The second thing is to configure the forwarding rules by means of directing traffic, for example, aggregated traffic for a particular mobile node, to one particular port. So all traffic for this mobile node will then experience the same set of properties, and the role of the DPN is to enforce these properties. For example, encapsulation to a tunnel with a certain tunnel endpoint. And packets is sent further. So this model can be mapped then on a router, and that's the role of the agent, to the router configuration to set up a new tunnel interface and to specify the associated aggregated or per host routes. Next slide. That's a different representation of this construct that is only valid and visible between a client and an agent, because here we are agnostic to the DPN node, whether it's a router or a switch. So it's just visible a set of grouped properties, which are described here. And the forwarding rules direct traffic either in an aggregated, in a per flow, or in a per host way to a particular port, and this kind of traffic experiences then the same set of properties. Next slide. So the current draft specifies a larger set of messages to treat this kind of policy model and configuration. So there are messages to add, delete ports, to add properties in terms of a tunnel property or a QoS property. That's the policy configuration part. There are messages to add rules. The rules are forwarding information. So the LMA control plane can make use of the client to bind certain traffic, for example, an aggregated traffic by means of mobile node's home network prefix, and forward all traffic to one of the previously configured logical ports. We thought about some events which may need to be reported from the data plane towards the control plane. So we considered some event registration and some messages which actually deliver these events and the current status of this monitored event towards the control plane. Next slide. Messages carry attributes. So this is a set of identifiers, client identifiers, agent identifiers, EPN identifiers. Next slide. These are properties. So far, the draft specifies properties for tunneling, referring to the tunnel type, source destination IP address, or properties for address translation, properties for QoS, or next hop properties for a remote gateway. Next slide. These are property-specific attributes. For example, if we have a GRE tunnel, we need more information which are GRE-specific, so sequence numbers, keys. If we have GTP plane encapsulation, we have to specify the tunnel endpoint ID, which is HTTP specific. Next slide. So here are some examples how that works. This is PMIP again as a use case. There's the access network running two MAC control plane functions, sending a PBU for a new mobile node arriving at a MAC 1. So the LMA control plane has the client function associated using the FPC protocol to talk to the agent. It does not know if the DPN behind is a router, a switch, or an access controller. It sends information about a new port because it needs a new policy configuration set and its properties. So property for a tunnel policy and properties for QoS treatment. The agent's role is to do the local configuration. We have a router here. So if the agent runs on the router, it uses certificate commands. It's a very abstract way. So tunnel 1 is set up, QoS policies are added, and last but not least, the FPC protocol is used to add a route. So traffic for the mobile node is directed to the new logical port, and all traffic arriving at this DPN will be treated according to. Next slide. That's doing the same, but in an aggregated way. So instead of 3 handshakes, the port configuration and the property binding can be done with a single message or that message. Rules need to be added. So in case of handover, which means the mobile moves from MAC 1 control plane to MAC 2 control plane, that implies a different MAC 2 data plane, which means only the existing property of the tunnel interface needs to be changed by means of pointing to the new MAC 2 DPN. So it's just a property modification, single message with the new properties to be sent to the agent. The agent performs the local configuration. Next slide. This is an example, the same manner here. So this is all the same here. Mobility protocol and protocol between client and agent. But the agent is not located on the router, and in this example, but on a network controller, for example, as a controller. And after arriving, after having these constructs being configured with the agent takes care about the SDN controller sends the correct flow modifications to the switch. Next slide. So this is the first draft from the working, which is what we propose to the working group. It's not complete, but I think it's enough information to convey the idea. What we need to do is we're well aware of some missing things, and we need a deep dive in the discussion of these open things. For example, some attributes are missing for event monitoring and QoS gateway. We started a discussion about autonomous operation of the client. If that's required, we need a kind of state machine and conceptual structures to describe. We also thought about orthogonal functions like discovery of the network. So the control plane needs to discover the data plane nodes which provide the required functionality in installation, QoS. So we may need to think about how do these components interwork with dependent functions, for example, for discovery. We need to adopt a suitable information or data model. So far in the appendix, we have an experimental description of a Young model, if you want to realize this by means of NetCom. If we choose information model, which is a more simplistic description of messages and attributes we need, we should at least ensure that there is interoperability and no issue with the interpretation of, for example, identifiers or QoS classes and their representation beyond the FPC protocol. So we may also think about the scope of the graph. Should more attributes or messages be in that graph? Or should be something taken out of the first graph and specification more simplistic? Next slide, which is the last one. So work team is well aware of some missing components where we need to converge to progress the job, but this is the work team's proposal to move into. And I would be interested in if you see this goes in the right direction. And if yes, if this could serve as a base for working the document or not. So many things that you summarize, hope some of you had the time to read the draft and feel it.
So we have 7 minutes for discussion.
Fred Templin from Boeing. So you listed a exemplary PMIP v6 exchange and control messages. Would you also be interested in considering arrow control messaging as another example?
I think this is kind of orthogonal consideration. If you go back to the example of PMIP, so I did not explicitly list okay. I did not explicitly list arrow, but arrow would be a protocol on the horizontal layer between, let's say, anchor and an access node component. So here's PMIP, GTPC, and I think arrow can be found on this horizontal interface.
Okay.
If you have a node treating the arrow control plane and needs to configure tunnels, forwarding information, whatever, in the data plane, your arrow component and control plane function would make use of this protocol to configure the policies in the data.
Okay. I'll read the draft and see how it fits.
Carlos Bernardo, UCDM. I think it's a good document to use as a starting point, so I'm in favor of adopting it.
It's working at least with the speakers, right?
George Karagiannis. I'm also in favor of adopting it. Of course, I was part of the team, but
John, I have a question for clarification actually in terms of what is the relationship between this and other things like forces or open flow and so on.
So there is a lot of work going on in working groups and Markov activities in discussion. So there may be some kind of synergies. This protocol, and that's why we decided to go for an information or data model, specifies the requirements from the viewpoint of mobility management. We have functions in the application space which are for mobility management. They track going on. So we need some dynamics in the policy configuration and update in the data plane. So we specify messages how to do this. Clear implementation using forces, netcon, whatever kind of protocol, that's the next step. So this document is meant to specify the attributes, actually the full semantics we need. If there are existing protocols which have messages already specified and implemented, serving the identified set, also attributes, they may be added. If they exist already, reuse them. So concrete implementation is something we see in the next step. Here we want to have a more or less complete document to drive the use cases which we have in mind and will be specified in a different way. And a clear concrete implementation should then be derived from that information model. The only thing, if you go for an information model here, or data model, is that we should really have compatibility on the northbound interface of the client functions. So if you have forces here and netconf here, as an example, the attributes being used by the application should look the same way. Right? So we should not have a different representation of data plane node identifiers, agent identifiers, and QoS policies. So that's the only thing we may need to have in a standardized way.
I'm wondering why the QoS is included in the mobility management here.
Repeat, what is included?
Why the QoS is included in the attribute? QoS, yeah. Because I think it's about the mobility management, and I can't understand why the QoS is included. Yeah.
So QoS is something that is considered in current mobility management, not by mobile IP before mobile IP6 or even per se, but there are extensions for QoS treatment, at least for proximal mobile IP6. So if the control plane has some means to negotiate QoS, we need to have a means to enforce the associated QoS policies in the data plane. And that's what this protocol at least should convey in the control of the data plane.
Okay, so let's go to the last slide. The last one. So on this last slide, you ask for the whether the work group should adopt the documents, and I assume that you refer here to draft working team DMM-FBC CPDB document, right?
This one.
Yeah. Okay. I didn't see it mentioned there. So okay. To my understanding, there hasn't been a counter proposal at the moment. You are the only one who have a draft on this topic. Yeah. Okay. So let's just take a quick sense of the room, what the others think about whether this work is mature enough to be adopted as a working group document for the work task 1. So the and now it's the time, like if you don't, couple of things. If you don't like the work, express your feeling, and if you think this is not mature enough as a basis for the working group document, you are free to express that also. So first, let's ask the question: who are in favor of adopting this document as a basis for the working group document for the working task 1 topic? And now you can raise your hand. All right. And those who think that the we should wait and not go for this document, but look for the future if there is something coming, raise your hand. 0. Okay, 1. Okay. That sounds like a rough consensus. We will, of course, post the same question on the mailing list. So but this is a good indication that there is a kind of energy behind this work. So I'll clarify the question again on the mailing list, and we go forward from them.
Unrelated question. So we had similar polls for the hybrid access document, and I believe even for the Charlie's other document on the NAI extensions. But
the data left for the last 15 minutes. We asked the stuff there. So
okay.
Sri, you are next one. That's the yeah, that one. All right, you have exactly 24 minutes.
Yeah, there's an update on the work team 4. Next slide, please. So, a couple of things. I think from the DMM, last year we had a number of discussions on this, overall DMM architecture, right? We had a few con calls and we had face-to-face meetings in the IETFs, and we had once, at least twice, I did the presentations. An update to that work, and essentially, overall, trying to see, how these different work items, fit into the overall grand scheme of DMM architecture, and also identify the deployment models. So that's the scope of this, work item. Right. I think first thing, what are the key things, right? What are the architectural principles, or what are the goals of this DMM, right? So point number one, we want separation of control and data plane. That is the basis, for this, for this all the work items. And you have just seen, Marco's presentation on, when a mobility function, when there's a control and data plane functions are split in a mobility agent, the interactions were captured in the CPDP interface document. So that is, number one. So the next one is essentially, aggregation of control plane. In this DMM, what we are saying is, aggregate the control plane, right? Centralize the control plane so that, you have interworking with policy and essentially, to all the other not-one interfaces, you have one central view of the entire, network and, control plane data, and also the policy data, right? So centralize the control plane and distribute the data plane. Distributing the data plane is with the motivation that essentially you distribute the data plane, you can use an efficient use of network resources, right? I can use any data plane node, I can re-anchor the session, a subscriber session closer to the radio, or move the anchor closer to the gateway, right? If you look at in the last Tuesday's presentation from the other, work team one or the other document, it was more about how you re-anchor a session. So that is essentially, if you have the ability to select a gateway, a data plane node, closer to the radio or closer to the user, or based on other considerations, that gives us many optimizations in the network. We can realize many optimizations in the network.
Try to stay in that area. I know it's hard.
All right. So the aggregation of control plane, going back, I think the goal is, it will give us the elastic scaling, right? From the service provider point of view, if they have this data center, they should be able to, have, in theory, any infinite number of resources, as needed on demand, activate new, schedule new services or new boxes, and essentially, load the, new sessions. And from the data plane perspective, one of the key motivation is, get rid of the any of the mobility state. All the data plane nodes should be very simple. All the state that should be in a forwarding entity is just the forwarding state, just the routing state. Nothing about a subscriber, nothing about subscription data, nothing about the mobility. A controller should, or a control plane agent should be able to tell the data plane that, set up this forwarding route, or set up this policy route, or set this QoS. That's it. It should be at the basic primitive level. If we can realize that, essentially what we are going to have is an architecture where we have a simplified, data plane. So that is the fourth, the motivation or the principles of the DMM architecture. And coming back to other, attributes or, other key things, right? Essentially, the dynamic selection of control and data plane node. A subscriber session, is getting activated. At that time, the network should be able to say that this particular subscriber session requires this particular type of features. For example, it may require a deep packet inspection feature, or it may require some crypto resources like IPsec resources. So based on the resource requirement, the controller or the network should have the ability to select a deep data plane agent which has those properties. In other words, select a gateway based on the session requirements. Right? In my network, I may have 10 different types of data plane resources. One with DPI capability, another box with simple forwarding capability, another box with essentially some IPsec capability. If I have the ability to pick one based on the attributes, it gives us a flexibility. Yes. Dan?
A quick question. You said, and we agree, that the control plane is centralized and the data plane is distributed. So in the bullet, dynamic selection of control and data plane nodes, I think we have one control node and many data plane nodes.
Yeah, I think that's a very good observation, right? I think how you view the controller, right? I think it's just somewhat touching an implementation aspect, right? Do you decompose the control plane? In theory, I can have one central controller, and in between, I can in the same cloud, I can have a zillion virtual machines with individual instances. But we are centralizing the control plane in the sense. Yes.
I agree.
Right.
But as you said, this is an implementation issue of the control node. So I don't think we need to. I think it's out of the scope of our working team.
Depends on how I think we can document it. I think we have to see. I think at the time of in the IETF document we can see how to present this. But to most part, this may not have any protocol extensions or anything. It's just matter of information text. Yeah. The other aspect of the enabling the mobile node with the network awareness, right? In the current mobility system, we haven't enabled the client with any network awareness, right? In the past, I introduced this work on the prefix coloring, almost 4 to 5 years back, right? We published 2 documents in DHC working group about essentially enabling coloring prefixes, right? Essentially the concept that prefixes are different properties, right? How to present those properties and how to deliver those deliver those properties as additional metadata in address assignment procedures such as DHCP or IPv6, right? We talked about it, right? But somehow in the context of mobility, we would need to identify specific attributes which are which are relevant to this work, and we need to work with other groups like MIF working group, which is doing similar work, or we need to present some extensions. I think Alper's work in this has some documents covering that, or any other documents potentially should be able to bring that in. The other point, I think I touched on this, relocation of anchor functions, right? Essentially, in the current architectures, to most part, our mobility anchors are fixed, right? Our starting point, once a mobile node in a PMIP v6 domain or a MIP v6 domain attaches to an anchor, that session is anchored to most part, right? We never have, we don't have the ability to move that, re-anchor that session to a different anchor, right? So that, in this context, is a key requirement. I think some of the work that, presentations you have seen, touched on that. I think, this is another motivation in this larger context of TMM. Next slide, please.
Yeah, a quick question for the relocation of the anchor point. Is there session continuity when you relocate the anchor?
That is the assumption. Okay. Yeah. Okay. Next slide, please. Yeah. Now, what are the building blocks? DMM is a domain, right? I think we have to introduce the assumption, we have PMIP v6 domain. There is a DMM domain. Now, in the DMM domain, there are certain mobility functions. One function is, essentially a control plane anchor. Another function is a data plane anchor, right? So now we are still preserving the home and access, semantics, right? I think if you look at today's mobility architectures, access is where it is closer to the radio, right? Typically is where the user is attached to the E-node B or the S gateway or the wireless LAN access point. That is somewhat the access network. And you have the home network where your classic, the home agents or the LMAs or P gateways are relocated, right? So that, essentially in the DMM domain, in one variation, we still, have this concept of a home and, anchor, right? And in home and access, and if you look at it, you have the interface between the access DPN and the access CPN. This is what the CPDP interface that Mark talked about, Marco talked about it. Or between this interface, home CPA and home DPA, right? This is where essentially the home CPA telling a home DPA that, I want to create the following IP forwarding state for this subscriber session. This is between this interface. Now, the protocols, MIP v6, PMIP v6, Aero, or whatever protocols typically, exist on this path, right? To most part, at this point, we haven't identified many extensions on this layer, but, there could be, as if we have to apply DMM to different architectures, like, PMIP v6 or Aero or whatever, individual protocol extensions may be needed, but those are on this plan, right? Essentially, assuming that, this becomes in one scenario, access CPN becomes like a MAC or a S gateway or whatever, right? And the home CPA becomes a LMA or a HA. And this interface is essentially, I think using Marco's document, it identifies the requirements. But I can also realize the same on a CAP-PAP interface. If it's a wireless LAN domain, if there's a CAP-PAP controller, potentially this could be using, I can map the same things on CAP-PAP or CAP-PAP and realize the same thing, right? But that's a, reference, a requirement document, but potentially we should be able to realize it in different access architectures. Next slide, please. Now, mapping of the functions, right? If you look at, we have the, IETF mobility work we have done, we have extended, PMV6, MIPv6, right? Ignoring MIP4 for now, right? And we have the 3GPP, 3GPP2 SDOs, right? In all of this, essentially, potentially, how can they, how can we map this, home CPA or home DPA or access CPN or access DPN to, potentially to the functions that exist in those SDO architectures, right? Essentially, each of this, the functions today, for introducing CP and DP split, we need to, introduce the split aspects, right? Essentially, if, for example, if we split the P gateway into, P gateway control and P gateway data plane, we need to introduce new functions, right? So those functions could be, should allow exactly like what the HCPA should. If I split the P gateway, as P gateway CPA and P gateway DPA, that becomes essentially, if you introduce the HCPA function on the P gateway, that will, essentially have the control plane function, and the data plane function should be the P gateway DPA, right? So this is the mapping to different, access architectures. So that is the just information. Next slide, please. Now, I think we talked about essentially the ability to select data plane anchor based on the session requirements or based on the policy is one of the key aspects, right? Like I said, if a given subscriber session requires, for example, a deep packet inspection or some other service which exists only on, for example, on this particular home DPA, when the subscriber session is getting activated, I should be able to pair up with this home DPA and with this home CPA and have the session anchored on that node. That way, that session, all the user plane data for that session goes through that node, and potentially whatever features that we want to apply can apply it on that node. So this is I think the key thing that we are introducing in this, bringing in this into this DMM architecture is this essentially the ability to, on demand, pick a data plane anchor and host the subscriber session and, essentially, serve that, provide service to that node. That is the key aspect. Now, this essentially, as Danny was talking about, in one sense, I can look at it as, one black box, or, I can decompose that and essentially say that, control plane is individual VM instances, and then there's a controller which is, which is doing the orchestration, right? But this, to most part, will have more like informational text, but I think this, we need to understand that most implementations will, will follow similar structure. Next slide, please. On the aspect of DPA selection, what are the, what allows the controller to pick a particular data plane anchor, right? Typically, it's the data plane capabilities, right? For example, I set IPsec or internet offload a particular, for example, a given DPA agent may have an internet exit point, internet peering point. It potentially can offload the subscriber traffic, right? It can potentially, when that node is configured in the controller, it can be, that property can be marked as available on that particular node, and then the controller should be able to pick that particular node, if there is a need for that service, right? So that is, one aspect. Also, the selection can also be based on other criteria, right? Essentially, this is based on the box capabilities, but there could be also be based on, driven by the policy elements at the controller. Potentially, you can say that all particular, subscribers for this particular group have to be anchored on this particular, DPA. That's a policy decision. Yes, Sui.
Yeah, can you do that like a chaining?
Chaining.
Path chaining, something.
Chaining is if I go back to the previous slide, please. I think so. Yeah, let's take, in this particular, if a given subscriber session is anchored, on this home CPA. On here home DPA, right? Potentially, this could be the root anchor, or then potentially, or this could be like a, if you look at the 3GPP architecture, this could be a TVAC, and there can be another, northbound, another signaling to another, anchor like a P gateway in the EPC, and this home CPA can be talking, doing control plane signaling with that particular node. So the chaining is part of this in the control plane. It can be, can be enabled.
No, I mean chaining means you have the IP acceleration, you have DPI, you have multiple service there, and then you can define the paths to go through this kind of chaining.
Oh, service function chaining. Oh, okay. Absolutely. So yeah, I could not capture that. That was one of this slide, right? So I think this comment goes back to let's say a subscriber session is anchored here and the user plane is anchored here, right? So somewhere in the policy decision, let's say if all the traffic from this particular DPA for this session needs to go through this some GLAN or some service chain, that is essentially comes in the form of an interface between the home CPA and the home DPA.
So I think the IPsec and DPI is like not GI interface. It's more like inside the data plane anchor point, right?
Repeat that again, sorry.
I mean the DPI and IPsec is more like today is already inside the P gateway. It's not the GI line interface.
Yeah, it is true. I think there are two things. If you want to apply some features on a service, on a 2 days like GLAN, right? Potentially all that needs to happen is this home DPA should be told, where to steer the traffic, right? Essentially, it can say that, there is another data plane here. All the traffic from here needs to go through some virtual cloud, right? That subscriber's traffic can put the right service header and route it through that chain. That's one case. And what I talked about, the IPsec and other things are not the GLAN features, but the features for example, for some control plane security or whatever. If you need a box, with that capabilities, it's about selecting that node for those requirements.
Okay, can we continue the process? You still have 7 minutes time, so that we can actually get through the.
Okay.
Yeah.
2 more minutes and then.
Okay.
Yeah. Next slide, please. I think the question of what is the security model that we are going to adopt for DMM, right? I think the view is essentially the use of what we have been doing with the other mobility protocols and other things in general. Use of essentially IPsec in ESP in transport mode, and use IQ2 for control plane negotiation. These are standard stuff. If potentially the text we can have it in such a way that if there's some SDO specific alternative models exist, we should be able to leverage that. But in general, I think it's IPsec, IQ2 is the default approach. Next slide. Yeah, I think I'll quickly touch base on the deployment models, right? Next one. Yeah. So I think this is a very simple, if I take today's, mobility system, and if I split it up into this, essentially, this is the approach, right? Essentially, there's a home CPA. Like I said, the protocols are on this layer, and the user plane is here. There's a CPTP interface, right? Essentially, there's a routing layer. There could be potentially a transport controller, but this is the big picture, right? In theory, there's no mobility state on these nodes. There's a simple forwarding. All there is simply forwarding state. All the protocols or the control plane state is just on these nodes. Next slide, please. A variation of that is essentially, I think there was a strong use on having a flat model, right? In a flat model, it's essentially, it may be, applicable in some scenarios where the network's, domain size is smaller, right? There's one, control entity which is, talking to the access DPNs and the home DPNs, and it's a converged, the converged, home and access, right? Essentially a single controller. Next slide, please. This is essentially about collocation of the home and the access DPN functions, right? For a subscriber session, let's take this mobile node. It initially attached to it initially attached to this node here, right? Our assumption is wherever it starts, that becomes the home anchor. All the the traffic, there's no tunneling, there's no special routing requirement. The device gets an address from the local anchor, and essentially the routing is optimized, super optimized. Now this device moves to this node here. Essentially, we still have the anchor there for that particular flow, but there's a secondary IP session or the gets created. For that, the new anchor is here. The idea is that over time we want to deprecate this session, or this flow, or this IP address, right? And migrate all the if the device activates any new IP sessions, in theory with the ALPulse extensions or whatever, if you match or other document, if you match it, if you publish the properties correctly, the device or the application should be able to start using the local address. That way, now there's optimized routing. Only the flows which are established prior when the device was here will go through this path. All the other flows will go direct. So this is essentially, I think the key things that we are bringing into the DMM is essentially the ability to pick an address, pick an anchor closer to you, closer to the device or radio, and then that becomes your home anchor. Later when you move, again pick a new anchor and systematically phase down the deprecate the old IP address or the old IP session. That's the key basis. Next slide. Essentially, there's another model. There were some views on here the concept of home disappears, right? Essentially, there's always routing updates. I'm not in favor of this. I don't know how this works, but in general, if a device anchors here, later it moves here, the anchor moves there. For that to work, in theory, that needs to be like a 32-bit routes or whatever, right? There has to be a lot of routing churn. But this is one model we have to capture. We did capture this. But that is, essentially the idea is simple. There's no control plane signaling. There's only data plane nodes with similar properties, where the device is always anchored on a given node. There's no tunneling or any other approaches. That's just maybe one quick just one slide. Yeah. A quick call flow. M1 attaches to access CPN, and the home talk signals using our classic MIP v6 or PMv6, whatever, right? It talks to the home CPN. At that time, at this point, the access CPN selects a data plane node. This is important, right? This selection is, we are not saying how it's happening, but here it selected this particular DPN node, and here the home CPN is selecting this home DPN node. So the data plane nodes are selected mainly on this side. Actually, it's not on the access side. It's mainly to on the home side. And then the user plane traffic is between the DPNs, and the control planes traffic stay in this path. Next slide, last slide. Yeah, this is for a flat model, right? Essentially, there's one single controller with and essentially data plane nodes, right? It's a set of messages to how it example. Yeah. Comments, questions?
That's basically one time for one comment. Okay.
Only one?
Yeah, be quick.
I'm trying to see why you distinguish between a node and anchor. If in one of the picture, for example, if this in the CN's network, every node is called a node, not an anchor.
Right.
But a different view would be to call that an anchor. So like you had two anchors, one anchor, the other anchor, they go together. But you distinguish them, so I don't see the reason to distinguish them into two separate names.
Right. So if you look at today's, LMA or MAC, right, the session is anchored. The true anchor is the LMA, right? MAC has a route to the anchor. Right. So even very earlier, I was using the terms anchor, even access CPN, but based on the comments and feedback from Marco and other number of people, I changed it because the true anchor from the routing system point of view is only the home CPA. It's not the access CPN. Access CPN has a route through the tunnel or through other means, but that is not the true anchor. The true anchor is the home. That's why we just wanted to. We thought we'll give the anchor only to the home.
So in your presentation, the anchor means the IP address is over there.
Anchor.
So the other ones you don't call that anchor. Okay, I just want to clarify that.
Okay. All right. Very quick one.
Marco, just a brief comment, and I think what we point to is a valid point. So for the deployment and also for the protocol between the control data plane, so we should consider in our discussion that the data plane functions required by the control plane are not in a single box, but chained using a service function chaining mechanism.
Absolutely.
Okay.
So I hope that can be transparent to the control plane, but we need to take such a setup into account.
Okay.
I think it will be transparent to the control plane, but I suspect there may be extensions on the CPDP interface document. Potentially, we may have to deliver a service header or something. I do not know. That needs to be.
All right. Thank you. And Satoru-san, you are the next one. And try to stay inside the red box. Okay, 10 minutes time.
Hi, this is Satoru Matsushima from SoftBank. I'd like to share about our draft update. I think you know already well about what my drafts describe about the architecture of the stateless user plane for the virtualized VPC. So this is the fourth update draft. The summary of the update from the third version to fourth version is here. Is like almost he makes things clear more and more, and also includes the working item of the charter DMM. So this is the Markov draft and working team. The forwarding policy configuration protocol as the mechanism to expose and extract the control plane states of the mobility management to the BGP speaker. As you know, the BGP has a protocol to inform, advertise the control plane state to the data plane node. So the other thing is we clarify more about the handover and the UE detachment in the section 3.2 as the clarification text to make things clear, to depict the simplified with the depicted simplified call flow of handover and UE detachment. Okay, next slide, please. So the next step is, so with this draft is to aim to contributing to DMM chartered item, such as for working item 3 is that try to describe more detail of how FPCP could be applied in budget PC architecture. So then it would be helpful to make feedback to FPCP work. So next thing is, so work item 4 is like this draft should be the one of the deployment model of the work item 4. So then that makes feedback to the work as well as the work item 3. Or so we don't have the draft or document to mention the work item 4 so far, but we are currently work with the 3. But this draft would be the kind of the one working item 4 draft. So if the working group interest to adopt this draft as the one of the working group document would be one of the choice, I think. So the other thing is the if someone contrive any idea for the other work items, such as work item 1 and 2, please let me know, and then we can figure out what could be helpful to moving forward the DMM work. That's all.
So question is, do you think your solution is aligned with the architecture as 3 just presented? So I mean, your solutions, does your solution align with the architecture as 3 just presented?
I'm not sure, but as you know, this architecture idea come out before the the architecture of the 3-dimensional bar. So I'm trying to align that's the idea and architecture. But if the things is not aligned, I think it would be a good clarification the architecture or the idea should be covered.
I think from what I understood, or I think it's aligned. I think if you look at the deployment models, I think one of the scenarios exactly documented this particular work. So, but I think we should ask comments from others overall.
Brett Templin from Boeing. So I noticed in your document you referred back to some work that was done by Boeing on BGP many years ago. Have you also looked at RFC 6179? That's also another document by Boeing that talks about using BGP for distributed mobility management.
So the Boeing BGP would become kind of the idea to use BGP as mobility management server. But in my draft, BGP as the protocol to inform the kind of the mobility state to install the forwarding node. I think it would be different purpose of the BGP employed compared with your draft. So when we discuss about that, Honolulu or the IETF meeting, the kind of your arrow would be the horizontal protocol, but we use it as the vertical protocol.
Okay. Yeah, I'll take it off list with you maybe.
Yeah, I understand and I read your idea and RF that I will see.
Yeah, I think this work exists for quite a long time, and I think it pretty much fits into work item 4. So it's a particular deployment of the deployment which are described in Sri's document. So I so far don't have a view how far this document goes. This is pretty concrete about an implementation, and either it goes into this document or can be treated as a separate document. But I think it's worthwhile to really keep this documented and public.
Thank you.
All right. So this was the last slide. This was the last slide, right?
Yeah.
Okay. All right. Okay. So let's see. So I think regarding that we have just recently started to talk about the actual deployment models and the architecture. So in a concrete way. So I would say that we take one more round, shuffle around, and whether this document could fit into the actual as a working group document for these deployment models. So I'm not willing to ask this question today. We can do that later on. But So no adoption call today, but I just want to get the feel of the room, like especially because I want more people to work on this, like giving more feedback and like trying to fit it correctly into the architecture that we have. So. Assuming as a forward-looking step, so who in the room are interested in this work and willing to contribute it and drive it into the possible as a candidate for the adoption of the working group on the deployment models? Just show your hand. Eight or nine, okay. And who thinks that this is not in any way into the fitting into our deployment models? Okay, no one. Okay, good. Any comments?
Yes. So
who are you?
This is Alex Petrescu. I work at CA, it's a research institute. The question I have is this implemented in some platform that could be used by a researcher or a student, or is it somewhere open source, or can it be done in open source somewhere, or is it something completely proprietary in a particular vendor platform?
Actually, there's some part of the architecture, there's some part to be implemented in the system. For example, EPC part and also BGP part and forwarding node part to reach the extension of the BGP. Especially the extension of the BGP, we have one implementation from the cooperative vendor, but it's not actual vendor specific, because that extension is based on the other parties' work. But the rest of the part exists in the EPC part. We don't have implemented so far.
Yeah.
So then there's no working.
Okay, I will ask you in private about this, but EPC is not something that people implement at universities, or EPC is something that vendor and router equipment manufacturers sell to cellular network operator under the auspices of 3GPP.
Yeah.
That is EPC.
Yeah.
Okay. Yeah. Whereas here, we look. In my setting, we look more like if we can download some open source software from a website and try to play with it.
Understood. So this is definitely a hard thing to get the working EPC, but I've seen demonstration where people actually hack a similar type of deployments that pretty much mimic the functionality, for example, what Carlos and those guys have been doing. So you can get pretty close on the functional side. You don't have all the knobs and stuff there. But that's a good point. So let's continue that on mailing list, so we go forward so that we don't get behind on the agenda. So thank you. And Danny, you are next. And try to be quick. I will cut your after 10 minutes. We will, yeah. If you want to point the laser beam. So you have 10 minutes starting now.
Okay, so I was asked to go quickly through the slides to leave room to discuss the on-demand graph.
Yeah.
So in the mobility state exposure team, we talked about enabling applications to request a certain type of service from the network through something like the socket interface. For example, ask for a fixed IP address or fixed service, or sustained or nomadic service. And one of the questions were, okay, so there's an API, the application can request something from the IP stack, but how does that get to the network? And we detected various protocols which we feel we need to enhance in order to convey this request to the network. One of those protocols is IPv6. This draft talks about how we need to extend IPv6 to enable the IPv6 client on behalf of the IP stack of the mobile node to convey to the network what the application is requesting, and for the network to be able to convey to the mobile node not only the source IP address that was assigned to it, but also the type of that source. Now, can you move to slide number 5? Okay, so a quick reminder on DHCP. DHCP defines various messages between the client and the server. Messages carry options. There are all sorts of options. Some options can appear in a message. Other options can only appear as encapsulated in other options. For our case, the interesting option is the IA address option. This option carries a source IP address. And it is encapsulated in another option. We'll not get into that right now. A client may use this option to hint to the network as to if it requires a specific IP address or something like that. The server doesn't have to accept the hint, but it can. This option is more used on the messages from the server to the client, conveying the IP address that was assigned to that mobile number. Next slide, please. The IA address option has a field in which it can encapsulate additional options. One example is the status code option, which provides status information which is related to this specific IP address. Next slide, please. We are proposing to add a new option. We called it IP continuity service option. This option will be an option which is encapsulated in the IA address option, just like the status code option, and it will carry the type of the IP address which is related to that option. In messages from the client to the server, this option means conveying the request of a certain type from the network. A certain type, we defined 4 types: sustain, fix, nomadic, and don't care. In the reply messages, the DHCP server will provide with the IP address the type of that specific IP address it assigned to the client. Now, it's a very simple extension. I think it fits very well with DHCP. Of course, we need to, after we discuss it in our group and agree on that, we will have to carry that to the DHC group and request their support as well. Thank you. Questions?
Fred Templin from Boeing. So I think as a mechanism this is okay, but my understanding of what happens when you get an address back from the DHCP server is that you're supposed to assign that address to the interface over which you made the request.
That's right.
So if you get back, say, a fixed address and a nomadic address, and you assign both of those addresses to your interface, how's the application going to know which is which?
Okay, so this is something that needs to be implemented in the IP stack. The IP stack needs to keep track of what the application requested, and when it gets the reply, to assign whatever IP address the application requested.
So it sounds like you need for the stack to get involved with DHCP client-side functions then?
Yes. Yes.
Okay. And there's also the question of what happens in the network. So in the network, you send a packet that's got a source address of a nomadic address, for example. How does the network know that that's a nomadic address and not a static address or stable address, whatever it's called?
Okay, so I just want to make sure I understood the question. You're asking when the client sends packets, it already received an address, it sends packets, it uses some source IP address. How does the network know what type of address that is, right? That was the question?
Yeah.
So my answer would be that the network doesn't care. As long as it's a valid source IP address, the packets will be treated. The interesting thing about that is when the client moves to a new location, all nomadic addresses cease to exist. Okay? Now, applications that don't care about that because they can recover by reopening a socket or some other means will be happy to use those type of IP addresses because they don't have to suffer from routing inefficiencies or tunneling or various things that a network has to do in order to support sustained IP addresses. On the other hand, when the mobile node moves, sustained IP addresses will continue to exist. So applications will simply continue to use the socket interface to send packets or receive packets. They won't be even aware of the mobility event because they don't care.
Yeah. I guess my main concern is that this is a very simple mechanism on the surface, but there's a lot of details down underneath.
And we will be happy to receive any help in the development of this draft. It's just the first revision.
I'll take a look at your document.
Thank you.
Be quick.
So just one comment on Fred's question that, essentially, once you configure the address on the interface, how do applications, make the distinction, right? So I thought one of the assumptions is this has an impact on RFC 3484 or the source address selection rules, right? The way host picks up an address from the stack, now it needs to be enhanced with these additional properties. So that's an impact to 3484 rules. So
that's already covered in the other draft.
Yeah.
Things plug in.
Yeah. So yeah. Okay.
So
Marco next, and then we go for the mighty question that I promised that we will do after this presentation. So.
Just a brief comment. So this is only to provide the conveyor for the hint and to get this particular requested IP address.
Right.
But it puts some assumptions on or dependency on the DHCP, which must participate then in anchor selection, for example, for a sustained address to provide an anchor.
Not necessarily. The HTTP server will have to convey this request to some management entity in the control plane, and will receive back directions as to which IP address to allocate, right? So the DHCP server doesn't know which anchor to select. And of course...
That's a dependency I was talking about.
Okay. Right. So yeah, so you're right, yes.
Okay. So, all right. So, on the previous session this week, the working task 4 asked for the exposing mobility state and so on. So ask for the adoption of the individual draft that they had been working on. So the draft Yegin on-demand mobility. And I said that we will make the adoption goal today. So now is the time. So there was a surprisingly heated discussion on the mailing list around that topic, which is great. So. So you know this, so it's not this one, but anyway, so, sorry. So the exposing, so working task that Albert was letting ask for a working group adoption on the draft Yegin on-demand DMM on-demand mobility. And we will ask that because that was asked a while ago. And so if you think that is a good basis for the kind of first draft on that topic, obviously there will be two parts. So the actual what needs to be done between the application and the stack, and then there will be following stuff like what Danny was presenting, like network to the host. Those will follow. So those who are in favor of adopting this draft as a basis for the working group document, please raise your hand. And those who oppose, please raise your hand. So we have 3. All right. that wasn't okay. There is a rough consensus. Okay.
Brian Haberman as shepherding AD. Those of you who raised your hand saying they supported the adoption document, would you raise them again? I almost got Alex. Keep them up. Now, of those with your hands raised, who is willing to put in cycles either reviewing or editing the document? Okay, thank you.
Yeah. It's going to be the same group anyway, all the time. Yeah. So, okay. Anyway, so we have to, of course, ask this again on the mailing list, but it's a indication that we have like a 1 to 3 people going for this. Yeah.
So I suggest you also to answer the questions raised on the mailing list and make some clarification of the document.
All right, let's go forward. So the next one is I think Alper is going to proxy this presentation, right? Alper, you are going to proxy this one. So, because I want to keep the timeline, you will have, how many minutes? Just a minute. You will have less than 10 minutes.
This is a draft from Sale and Sergio and Young Han. Since none of them are attending, they asked me to present this on their behalf. This draft is a further extension to the DMM API draft that we've been talking about. So let's go to the next slide. Okay, next slide. There's really nothing extra here, so for the sake of speeding things up, I'm not going to say anything here because this is all well known. Next, this is just background information. Now, one thing to note is according to the API, we have the API extension we have defined in the DMM API draft, the on-demand mobility draft. When an application requests a specific type of an IP address, that IP address may or may not be, that type of IP address may or may not be configured on the stack. If it is configured, normally the source address selection will select that IP address or one of the IP addresses matching the type. And if the address is not already available, then there will be a dynamic trigger. There will be a trigger to dynamically configure one such IP address. So that's the baseline that we have established in the other draft. And in this draft, let's go to the next page. Now, is this the last slide? Right, okay. The idea behind this draft is, so by the time application says, hey, I want a sustained IP address, even if the stack has a sustained IP address, the authors want to force the stack to go get yet another sustained IP address. The idea behind that is, the stack may have a sustained IP address and that may be anchored in a far, far away IP anchor. So imagine the stack having configured this sustained IP address many IP hops away, and it has stretched far away from that anchor node. Now another application is fired up, it needs a sustained IP address. Reusing the same sustained IP address would possibly result in suboptimal routing. So instead of reusing or latching on to the existing sustained IP address, now the application wants to say, hey, you know what, I want a fresh sustained IP address, which will most probably be more efficient because it will be most probably anchored on a nearby gateway. So this flag gives a way for applications to indicate that preference, okay? Still, the application will get a sustained IP address, but it will get a sustained IP address that is newly configured, which will have a higher chance of being on a more optimized data path. So that's the idea behind this draft. So this flag, if the working group adopts this, it would be an extension to the baseline API flag set. Yes.
This is Danny. I have a couple of problems with this draft. I also sent email to the authors. First of all, which application would prefer to be anchored to a far further away anchor? Clearly, all applications would want to be anchored as close as possible. So this flag is redundant. I mean, it's up to the, in my opinion, it's up to the IP stack to always prefer the most appropriate anchor and not wait for some flag to do something. This is one point. Another point is what this flag does, it tells the IP stack, I know even though you have IP addresses, go and ask for another one. Now how does the application know if the current IP stack is anchored further away or not? I mean, it could be just wasting resources by again and again and again asking for new IP sources, even though it's not needed. So
it may be abused, you're saying?
Yeah, so I'm not sure we need this.
Okay. I mean, okay, in the sense that I understand you. I'm just a messenger.
Brett Templin from Boeing. So in a system where the anchor is always close to the host, wherever it goes, would this even be needed? Because if you've got a system where the sustained address is always very close, the anchor is never far away.
Well, but we cannot guarantee that, right? I mean,
I have a system that can guarantee that.
Okay, so what you're saying is there are solutions that would never create a need for such a thing. Yeah. Okay, it would be good to maybe if you can elaborate that on the mailing list.
Sure.
Then we can
Okay.
follow up. Okay.
All right. But okay, just a clarification for myself. So, so you think that this kind of flags would assuming that for example draft Yegin would be adopted, this kind of flags could be added in your draft?
If this is accepted as well.
Okay.
Yeah. So this is an extension to our other draft.
Okay.
Which is subject to discussion. This is the first time it's being presented, so as long as people understand it, that's good enough for this meeting.
Okay.
Okay.
Okay. You done? Thank you. Excellent. We are ahead of time again. So let's go forward. So the next one is Jan. Yeah, that one. Read on point. So we have something that is okay. That one. Up, down. Prefix renumbering. Prefix renumbering. That one. All right. And you got 10 minutes.
Thanks, everyone. I'm sorry, the author of this draft, Dr. Yan, has flew back to China yesterday. So, as his colleague, I'd like to make this presentation. This draft is about the home network prefix renumbering in prefix mobile IPv6. Next, thanks. Well, the IPv6 prefix may be renumbered if it is not a prefix independent type. And for the home network prefix in PM IPv6 renumbering is also possible. There are three scenarios. The first is maybe the PM IPv6 service provider switch to a different ISP. The second is the PM IPv6 service provider may have multiple LMA. And one of the MLA may be switched to another in some scenarios. The third is the PM IPv6 service provider may recognize its network topology. So next. Actually, this scenario, there's a similar issue for the mobile IPv6, and in RFC 6275, a solution has been raised to solve that problem. The home agent will notify the mobile node actively, and then they negotiate with each other, update the IP prefix. Although this issue also was discussed in the RFC 5213, but the related solution has not been specified. And in RFC 1777 specify a scheme to support a update solution for the MLA to the MAC. So we think we might use this framework to realize the IP prefix renumbering for this issue. Next, thanks. So here is the proposed solution. First, a new HMP should be the home network prefix should be allocated when renumbering happens. Then the LMA sends the update notification message to MAC on the framework we mentioned in the RFC 1777. The notification reason should be set to 2, and the STP option, including the new SMP and the mobile network identifier, something like that. Next, please. And the third step is the MAC and the old HMP in the RA with 0 valid lifetime, and sends a new HMP in the RA with lifetime larger than 0. Then the MAC sends back the update notification acknowledgement to the LMA. Finally, the mobile node delete the old home address and configure a new home address with a meaningful SMP. If there's, if there's some DNS record related with the mobile node's IP addresses, some DNS solution should also be considered. So that is a draft. So we want to know, have your comments if this issue should be considered by DMM, and if this proposed solution makes sense. Thanks.
So one question. So you are thinking this as in maintenance part of the DMM for the PMIP?
Excuse me?
So you are proposing this work to the maintenance part of the proxy mobile IP?
Yes.
Okay. Nothing to do with the actual DMM. Okay. So any comments? Anyone thinks this is a useful work?
I think technically makes sense. I think use of 7077 to fix this is the right problem. At that time we couldn't fix it because we didn't have a message. If there's interest, yeah, it's fine. It's a reasonable fix.
Alex Petrescu. So will the renumbering imply breaking session continuity?
Pardon?
If we renumber, the sessions will continue or will have to be restarted?
I think it should be restarted. Anyway, the mobile end user, the mobile node changes type prefix.
So typically, when the MAC advertises both the prefixes, the other one should be in a deprecated mode or whatever, right? So based on that, the expectation is applications will migrate to the new address.
Okay.
Thank you.
Thank you. So I encourage raising the discussion in the mailing list, and those who actually think this is a good work, please chime in and help these people to make the a draft better, to cover all the possible cases and include things like what Alex brought up, like the how you actually, for example, do gracefully deprecate addresses and renumber. That's not a trivial issue. So, all right, thank you. So let's move on. We have one more presentation, and then we have some other funny stuff coming up. So Fred, go ahead. Yep. Do you need that one? The laser beam. Yeah. You are on.
Okay, so I just want to give some updates on the Aero spec since we spoke last at the last couple of IETFs. Next chart. So in the Aero spec, I've cleaned up the DHCP v6 prefix delegation. Arrow servers are running this implementation of what's called a lightweight DHCP relay agent. So they act as both relays and servers. The relay agent loops the link layer address of the client through the DHCP-v6 server, then back to the client, so that the client can discover whether it's behind a NAT or not. So then the other thing is the fragmentation and MTU specification is now stable. Tunnels will see at least 1,500 bytes and allow larger packets to fit the available MTU. So the good news about this is that we don't ever have to rely on packet too big messages to get the packets through that we expect to get through. A small amount of fragmentation might be needed someplace in the network, but it can be tuned down quickly if the available MTU is sufficient. So tunnel MTU is solved in this draft, version of the Arrow draft. Next chart. AutoConf, DHCP-v6 prefix delegation provides the client with an IPv6 or IPv4 prefix. The client sets a default route to the server automatically, configures an Arrow address based on the prefix and assigns it to the Arrow interface, so we get a guaranteed unique IPv6 link local address without having to do DAD. Client provisions delegated prefixes to other interfaces, so we get guaranteed unique IPv4 or IPv6 global addresses. And now the Arrow address is used in IPv6 neighbor discovery signaling over the Arrow link, and all the signaling protocols don't have to worry about address collisions. Next chart. Encapsulation within UDP or raw IP. There are no mobility headers nor any kernel changes. It's all user level stuff. There's a new encapsulation format called generic UDP encapsulation that's coming out of the routing area, and Arrow is going to adapt to use that GRE UDP encapsulation format. So Arrow would then be the control plane messaging, and the GUE is the data plane encapsulation. So Arrow would be a GUE user. Next chart. Mobility. DHCP-v6 renew rebind securely updates the server's neighbor cache when the client's link layer address changes. And unsolicited neighbor advertisements inform correspondent clients of link layer address changes in the same way that a mobile IP binding update would inform a mobility change. And we use IPv6 neighbor discovery redirect message for route optimization. Next chart. Arrow distributed mobility management. We can have thousands of servers within a single Arrow domain. Each server is capable of serving thousands of clients, and the servers can offload forwarding plane to fast path forwarding engines using forwarding control plane separation, as we've discussed in the earlier talks today. And the relays bind everything together with BGP. So BGP is used to keep track of what mobile network prefixes are assigned within the domain. Next chart. Implementation status. We now have a user-level daemon called ArrowD that runs on Linux with no kernel changes again. Porting it to Android and iOS. It uses the TUNTAP interface. I've implemented RFC 6221 and 6422, which are the DHCP pieces that are needed for this relaying. It works with the ISC DHCP-v6 package. I'm using that today, and we're going to plan to change to the ISC Kia DHCP implementation. That should be it. Oh, these are the documents. And notice this last one down here, this GUE, which is being worked out of the routing area. So we kind of have some cross-area pollination going on here. That's all.
All right. Thank you. Great. Just a second. Amazingly, we are ahead of our schedule. So we have a one quick surprise thing to do today. So we have been discussing. Okay, so this falls again to the mobile IPv6 and proxy mobile IP maintenance part. So there has been a request to consider the. You remember the Charlie's draft about updating mobile node ID? Can you bring that if you go to the...
Yes, I'm Charlie Perkins. Last fall, November, I guess, the mobile node ID draft was updated, and there was some discussion about it on the mailing list, and Most of the changes that were made had to do with providing more types of IDs about RFID. And the intention was to, request adoption from the working group as a working group document. It's really pretty much done, I think. It's almost delivered on a silver platter. But I didn't actually request adoption after the discussion there, and it was brought up to me today that maybe this would be a good time to ask. And so if there's the working group is aware of the document, and of course if there's further changes that can be made, but it's relatively a simple list of the kinds of IDs that would be useful to identify mobile nodes, and it does update the existing RFC for that purpose. So thank you for the opportunity to ask. If anybody wants to find out if there's an interest to adopt the document, I can pretty much expect a quick turnaround on any remaining areas that need to be improved.
Yeah. So I realized that this came like during this week. So if I will ask the adoption for this document, but if anyone is hesitant because like the so this is again about the maintenance part of the working group, and we've been actually working on this draft for quite some time, and but if someone feels like that having asking this question like without presentation or something like that, so please bring it up. But we'll do. Okay, Alex.
Yeah, Alex Petrescu. So I know this draft has been in the works since some time now, and I have followed the discussion on MNID, and I agree with most points that have been inserted in the draft. So an adoption would make sense, although I'm not sure whether it is in charter or whether rechartering is needed or not. But I think a call for adoption makes sense.
Yeah.
A side question that I had is whether this is still open for suggesting new identifiers, or is it something that we want to?
Yeah. So if we adopt the document, it's like any other working group document. So then it's like not Charlie's document anymore. So working group can affect its content right away.
Yeah. So we have worked on a new identifier to identify a car actually, and we have some.
Bring it in. So. Yeah.
Yeah. Okay.
Okay. So let's do a quick poll. So those who are in favor of adopting this Charlie's MNID BIS document as a working group document, as a basis for a working group document, please raise your hand. Seven. Yeah. And those who are against, please raise your hand. This is our time now. I see none.
Okay, thank you very much.
All right. So I will confirm this again on the mailing list. So, yeah. And I really hope that this is going to be a quick turnaround with this document, so that we can go for the working class call pretty quickly.
Well, right now I don't see any reason why not, but I think Alex wants to mention something about vehicular IDs.
Yeah. Okay. All right. Great. Thank you. So this brings us to the end of the agenda today. Sri wants to sing for us.
Yeah, so there's a song. So Peric had a document on hybrid access. So last time I think you chairs did a polling and there was support. Subsequently, you guys are supposed to do a follow-up, but that never happened.
I don't recall any discussion on it since.
Hybrid access document.
Yeah. Okay. Right. All right. Yeah. I hope that the kick some life to that document so we can do the same for it. All right. So I think we can quit today 20 minutes ahead unless someone has something important to say. Other than that, we are done for today. Let's see next time in Prague. And bye and thank you. And if someone hasn't put their names on the blue sheets, please do that. Okay. And John, please send them the minutes somewhere during this week. Raw notes, it's okay. Yeah, good.
So what product are you currently attribute? What product?
Thank you very much. I need to get one of those.
Yes. You start a study group, working group. Yeah.
No, we put a new project.
New project?
Yeah.
Okay.
So that's not enough.
It's in HO2? Under HO2? Attribute HO2?
No, it's under ComSoc.
Oh, okay.
So it's 1904 is a existing working group there and just a new task force.
Is that the product related to CMS?
Yeah.
Oh.
I just wanted to say you guys did a nice job of managing the time. I appreciate that.
I said that. Yeah, I know.
So, I did not come prepared today to ask any questions about whether this would be a working group item. But what would you think would be? What would you think would be a good way for me to phrase that next time we get together?
Maybe you need to kind of.
You can, I suggest you can join the work team, right?
Or then, the normal social stuff. You need to get these few guys going who are basically the long time pivot groups.
Right.
Or the new way of whatever. But I don't have a problem with asking this question.
Okay. Nice. Okay. Maybe next time we get together, I'll put together.
Yeah.
I thought Satoru did a good job of phrasing his in terms of the working items.
Yeah. So just like if you're going to do that, just let me know ahead of time.
Okay.
Not like I asked this one question because it was so obvious this mobile node identifier, but I would really like to get this week during the week or week before.
Okay. Yeah. I'll coordinate with you then.
Yeah.
So
right.
Another suggestion is I think you can also join the work team to discuss their.
Yeah, I had been on the work teams, but I had to drop off. I wasn't able to continue, but I'll see if I can get back on it again. Okay. Thank you both.
When are you back? Tomorrow?
Tomorrow?
I will take care.
Yeah. We have the best lady. Very good. As you know, you've been playing with our stuff before. Yeah. But the data centers you go for something else.
Keep in touch. Yeah, I will keep.
Okay, great. Thanks.
Yes, I know this, and I'm available. I have a room right now, but I can leave wherever you want. Okay, excellent. Okay, we got, yes, that's fine. We got that. Yeah, yes. Okay, okay, bye-bye.